For this week, we're going to be going over inference for one mean. So for number 3, it says a hypothesis test consists of two hypotheses: the null hypothesis and the alternative hypothesis. Which one represents the status quo? Pretty sure the status quo is the null.
What? Yeah, I think so.
Yeah, the null is what is true, so it's the same thing.
Yeah. Sweet. So that would be the null.
Okay, which hypothesis involves equality?
True.
True hypothesis?
I'm just double checking real quick. Oh wait, alternative.
I don't remember even reading about a true hypothesis.
I think isn't it null as well, the null hypothesis?
Yeah, I believe it's null. Because the alternative is either greater than, less than, or not equal to.
Okay. Well, is there no such thing as a true hypothesis?
I didn't read anything about it in the reading, so. Unless,
No.
did you guys?
I didn't hear anything about it.
Yeah, I didn't either. That's just weird. That's just thrown in there. Okay,
Yeah.
so we're going with null on both of those?
Yes.
Okay. Number 5.
The p-value is the probability of obtaining the sample statistic at least at an extreme as the one that was actually observed. Uses information to answer question 5. When computing this probability, which hypothesis do you assume to be true? So it's the alternative, right? Because we're trying to prove something other than what is generally accepted as true.
Yeah, but when you're computing, don't you compute off of the null and see if it's true? I'm not sure.
So basically, if either the phrase less than or greater than is used, the prediction is directional. So you will need to know how to tell the difference for your, let's see, a null hypothesis and an alternative hypothesis between two possibilities. The null hypothesis reflects that there will be no observed effect for our experiment, whereas the alternative hypothesis reflects that there will be an observed effect for our experiment.
Okay, alternative.
I'm just trying to read the sentence before. It says, obtaining a sample statistic at least as extreme as the one that was actually observed. What does that mean?
So when the statistic is observed, it would be the alternative hypothesis. And like it says in the question, of obtaining a sample statistic at least as extreme as the one that was actually observed. Yeah, so that would be alternative.
So you're agreeing with me? Alternative?
Yes.
5? Okay.
I am too.
All right.
Number 6, suppose the null hypothesis, mu equals 10. Use this information to answer 6 through 8. Which of the following represents alternative hypothesis for a two-tailed test? It's going to be not equal to. Correct?
To the alternative represents a two-tailed. Yeah, it's the C.
Okay,
Yeah.
cool. Which of the following represents the alternative hypothesis for a left-tailed test? For a left.
I got to look up left and right tailed. I don't remember what those were.
Okay.
So.
Would be a left-tailed alternative hypothesis test.
I believe it's greater than 10. Because that's going to put your tail on the, well, yeah, I'm going to do research.
Wouldn't it be less than? Because the left is going to be lower than the mean.
It says here that left-tailed test is, I don't know. So a left-tailed critical, the alpha criticals to the left, and the critical area for the right is to the right for the alpha. The two-tailed test is when you have critical areas on both sides.
Yeah. So yeah, I think.
So it's the opposite of our. You remember we had skewed data before.
Mm-hmm.
But if something was skewed to the left, it's anyway. It's somehow related. It's not exact. But it sounds like left is left and right is right in this case.
So for number 7, I think it's A, correct? Mu
Yeah,
would be
mu is less than 10.
And then for right tail, mu would be greater than 10.
Yes.
So which represents the left-tailed hypothesis? So A for 7 and right is B.
Yep. Number 9, I'm going to read the question first. Which right relationship would result in failing to reject a null hypothesis? And then the outcome of the hypothesis test is determined by comparing the p-value to the level of significance, or mu. Use this information for questions 9 through 10.
That is alpha. It's not mu there. But anyway.
Oh, alpha. Sorry.
It is.
Yep.
So level of significance.
It's a hard one.
Result and thing. What does Z mean again? Z-score?
The Z-score, let me see, I wrote it down.
Yeah, I think it's Z-score.
Okay.
Z-score is sample mean, minus mu, the population, divided by
Right, yeah.
sigma standard deviation. And
I know what Z-score is. I was just asking if Z meant Z-score for p-value, like on the 2 options on the bottom.
Oh.
I just wasn't sure what Z meant.
Which so in talking about P, it says if P is low, we reject the null hypothesis, or
Yeah.
if P is high, we fail to reject the null. So if P is greater than alpha, we fail to reject the null.
Oh, really?
Yes.
That'd be the first one then.
So if P is greater than alpha, we fail to reject the null.
Sweet. So it would be A for 9.
A for 9. And if
B for 10.
If reject the null if it's reject.
Wait. So say that one more time. If P is greater than alpha, then it is a result in failing to reject.
So, I'm just reading my notes. It says if P is low, we reject the null. So, but if P is high, we fail to reject the null.
Okay, yeah. So yeah, 9 would be A, and then 10 would be B. I was just making sure I heard that right.
Yeah. Okay.
11?
Yeah. An insurance company is reviewing its current policy rates. When originally setting the rates, they believe that the average claim amount was 1,500. They are concerned that the true mean is actually higher than this. Use this information for questions 11 through 12. Which of the following would be the appropriate alternative hypothesis?
C. The average claim is greater than 1,500.
Awesome. I agree. Backbone. That's a good ringtone.
So C for 11. Okay. Which of the following would be the appropriate null hypothesis?
A equal to 1,500.
Yeah, isn't the null just the original?
Yeah, just what the population believes.
Yeah.
Equal to A. Okay. That makes sense.
13. The insurance company randomly selects 40 claims and calculates a sample mean of 1,650. Use this information for 13 through 15. The insurance company assumes the distribution of the sample means is normal. Is this a good assumption?
No. Because 30, if we're still going off 30 as a big number.
I think it's 35.
Is it 35 in this case?
That's what I remember.
It's
Okay.
either 30 or 35. I think
So
it's actually.
I thought it was, well, in previous examples, I believe it was 30 is greater than 30 is considered a big number.
Yeah.
But so I'm saying no for 13.
So it's no because it is over 30. So
because it's greater than the 1,500.
Oh.
We're still
still
using previous questions, like 11,
okay.
to help us answer this.
Okay, gotcha.
Because it's greater than the, what is that, the greater than the null hypothesis, is that right?
Right.
Okay. What theorem or law justifies your answer to the previous question? Well, it's not total probability. We haven't talked about that one.
The essential limit theorem states that I studied this, that if all the sample means, like it said something about like if all the sample means, if the more you get, the closer you become to the population mean. And then the law of large numbers, that's still kind of vague for me. So, law of large numbers is a principle of probability according to which the frequencies of events with the same likelihood of occurrence even out, given enough trials or instances. As the number of experiments increases, the actual ratio of outcomes will converge on the theoretical or expected ratio of outcomes. So, if you're going off of the 30, if it's greater than 30, then that would be the law of large numbers.
Yeah.
So, wouldn't 13 be yes? Since it is
I'm reading over it again. I think it's yes. Because though it's different than that 1,500 that it reads in number 11, they came up with a new hypothesis, and it's larger than 30. I just don't see why that wouldn't be. Normal distribution.
Okay, so if we're rejecting that this question stands alone, okay, it would be yes. If we're referring to a previous question, it would be no for 13. So.
Okay. Well, I guess my thing is like if it's over 30, it's usually a normal distribution, right?
Yes.
Okay. Cool.
Okay, 15. Which of the following is the test statistic as defined in this lesson?
Test.
The test statistic. What does that mean?
Let me go back to that as well.
Would it be N?
Size. Simple mean. Population.
Test statistic.
That is a p-value.
So just to kind of, something I found is you can use the test statistics to determine whether to reject the null hypothesis. The test statistic compares your data with what is expected under the null hypothesis. And also the test statistic is used to calculate the p-value.
Wow.
And also a test statistic measures the degree of agreement between a sample of data and the null hypothesis. So if that helps.
Well, we know it's not Z, and we know it's not S. Okay, so it's either X or N.
Right. I think it might be N. For some odd reason, I feel like it's the number of population.
Test statistic. Kind of makes sense to me. What's the p-value, real quick? Do you guys know?
Let me double check.
I don't have a definition.
It says what you just read says that the test statistic is used to calculate the p-value. Yeah.
So the p-value is a function of the observed sample results that is used in statistical hypothesis.
That doesn't help.
More specifically, the p-value is defined as the probability of obtaining a result equal to or more extreme than what was actually observed, assuming that the null hypothesis is true. So it's a probability of getting the same hypothesis as what you had before.
Well, you use n and x bar to do that, so that doesn't help.
But don't you have more control over n than you do x bar?
That's true.
Well, I gotta take this real quick.
No problem. I would say n then. We have two things.
I'm still researching there.
Okay. I'll continue.
More extreme.
Okay, so I actually have a friend. She has the same class, and her group wasn't able to meet today, so she's gonna jump in with us.
Okay.
It's fine.
She's really smart too, so.
Economic philosophy.
Kind of stumped on this one.
This is a random value representing. Okay, here's something. It says in statistics. Am I getting loop now?
Yeah, I think so.
Yeah.
I can shut off my video. Maybe that'll make a difference.
Yeah,
I think it does. What were you reading?
So it says in statistics, a statistical hypothesis refers to the probability distribution is assumed to govern the observed data. If X is a random variable representing the observed data, and H is the statistical hypothesis under consideration, then the notion of statistical significance can be qualified by the, I don't know, conditional probability, PR, XH. So it sounds to me like X is the variable. So what we're testing.
Okay.
Is that, I'm leaning towards that. Yeah.
Okay.
It's hard because
Yeah,
X and N are directly correlated. Like N is just the number of like samples, whereas X is the average of those samples, right?
So the X is the sample mean, and N is the sample size.
Yeah. So they're directly correlated, so it's hard to. I'm trying to read and find where it just tells us.
Okay. Detailed test data. Did your friend join, or is not going to?
Oh, she's gonna just meet me here.
Oh, okay.
Well, maybe we can just come back to it.
Okay.
Yeah, like I don't know.
I'm going to continue reading while we do the other ones.
The historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. That's a hypothesis test. Which of the following hypotheses? So it's going to be less. So
Here, I think I just found it actually.
okay.
I want you to read along with me, make sure I'm doing it right. So go to individual preparation. On step 2, click on the reading that we have, the link for it. And then scroll down to 4.2.
Individual preparation. So you're on part 9, part 1? Or just the read inference of
step 2, it says,
okay.
Yeah, read inference 1 mean. Scroll down 4.2.
Okay.
Bottom paragraph.
I clicked on the wrong thing. Hold on just a second.
No problem.
So you're on p-value definition? Is that what you're referring to?
No, 4.2, just above that. Paragraph right above that.
Oh, okay.
Where Z is the test statistic. So we threw out Z immediately. But it's saying where Z is the test statistic, X bar is the sample mean, mu is the population mean. So is that saying Z is the test statistic?
I thought Z wasn't even in one of the choices.
Oh, isn't it?
It's S.
Oh, it is.
I thought S was one of the choices.
We've got X bar, Z, S, and N.
Yeah, you got it. So it says Z. So.
Yep. Okay, we'll go Z.
Yeah, I gotta go back to it because I didn't open a new window.
Did you hear that, Josh? Yeah, Josh.
Sorry, what's up?
So we determined it's Z.
For 15?
Yeah.
Oh, wow. That's what I got. It's Z?
Yeah.
Okay, go ahead and explain why it's Z, sorry.
And we just read directly from the notes.
Yeah, from the reading. If you want to read it, it's
one.
Yeah,
yeah.
In the case of right-tailed test, p-value is the area to the right of the test statistic, Z. Z is the test statistic. Okay.
Okay.
Okay, so on 14, I might have been wrong on law of large numbers. I don't know. We're gonna double check that real quick because it might be the other one, central limit theorem.
Okay, let's read 16. I'll read it while you're looking that up.
Go ahead.
The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypothesis. So she will use the level of significance of 0.05. She then takes the a simple random sample of 36 sales receipts from her store and computes 144. Use this information for questions 16 through 18.
Now I have to find out the z-score. Okay. I have to write it down. So x is 144, and what is the mean? Or the mu? X is the mean, 144. Alpha is, we're not using alpha, are we? Where does alpha fit into this equation?
I think it's a whole new equation from last week.
Okay. I just unmuted.
Oh.
For 16. Do you understand this one, Jones? I don't like this whole null hypothesis and alternative hypothesis. Oh man. Only a couple more to go, guys. We got this.
It's to 21, yep.
Okay. Okay. Null hypothesis 150. Alternative hypothesis is less than 150. Should use an hypothesis function 5.05 should anticipate. X equals. There should be some type of formula to use X bar, the null hypothesis, and the alternative hypothesis, and the sample size. Sample size is a no, that's prime g square.
Okay.
And then the null hypothesis or the sample size of 36. Oh goodness.
Oh goodness.
I think this is the last math class I have to take for my major.
Me too.
It's mine.
I think multivariable calculus.
Yeah, the one that my friend, she has to take multivariable calculus next semester.
Good
Oh.
luck.
Mm.
What's her major?
Math ed.
Math.
There's got to be some type of equation that we overlooked in the reading that uses the two hypotheses. There we go. And yeah, it's where it uses X bar and alpha of 0.05. We should simply just be able to plug it on in. Well, okay, what if we just did this? Because we know how to find a z-score. What if, so alpha is like, what's it called?
Okay, that one is essential.
I knew.
I told you that. You're the one who got large numbers. It's the central limit theorem. That's what I was telling
Wait,
you.
oh, okay, wait, why?
Because it's talking about it right here. The central limit theorem in lesson 6. We learned that.
X bar of no distribution. Or if the sample size n is large. Oh, dang it, it is central limit theorem. All right, guys, 14 is B, not A.
You sure?
Yeah, I'll put it straight out of the book. When your sample size n is large, then it's central.
Greater than 30.
When it's greater than 30, it's central limit theorem.
Cool.
Okay, so to find the z-score, we've done this before. So like your what's it called? What's the thing that we used before when you have x bar and mu and omega, which is standard deviations. So our alpha is now our standard deviation, basically.
I thought about it says standard deviation's 40.
What is the so this one?
Oh, you're right.
Z-score.
Oh, standard deviation is 40. Sorry, it's not alpha. I didn't see that. So all we'd have to do is do the square root of 36. Plus, and then take 40 divided by 6. And then take 150 minus 144.
Aren't we still? We're still getting a z score. We're just using the z score to calculate the p-value, right?
Yeah, I think so. I have the z-score. What'd you guys get?
Whatever you got.
So we're using 144 as the x, and then the
Minus 150.
sigma. Well, no, where are we using sigma? Isn't sigma 40 the standard deviation?
Yeah, standard deviation. And then you divide by 6 because it's square root of 36. Right. So the level of significance, is that's only used for p-value? For question 17. So 16 we could do last week.
Right, and I got negative 0.900 if you want to put it 3 decimal places.
0.9. I didn't. 900.
Yeah. And it is negative because 144 is less than 150.
Yeah.
So
Z-score negative.
Negative negative 0.900.
Yeah.
Yeah.
And then to find p-value, let's go back to the reading again.
So p-value is the same as the probability.
It's similar to probability. It's defined as the probability of obtaining a result equal to or more extreme than what was actually observed. So it's the probability of how close you're going to get to your null hypothesis.
And it's saying it's within 5%. That's what they're on 16. It would be significant if it's equal to 5% or 0.05. So did you plug in that z-score and we're checking to see if it on the less than side you know, I've got to pull up the app to see what it is.
Okay.
Um,
Is there anything?
This was showing me this. I'm like,
Yeah.
it's
It's like if we just go to the applet, we can use the app.
yeah, the normal probability applet.
Yeah. So when we plug in the z-score of negative 0.900, we use that.
Only select the left side.
Only the left side.
Yeah,
It's
Are you
'cause
sure on
it's
that?
supposed to be. We're using the data for 16 through 18, so of 16. So that's why we're only choosing the left side.
okay. So that would be an area of 0.184. 184.
So is that your p-value?
That's
Or is the p-value it's supposed to be the area, the top number. Yeah.
right. But I'm just not sure if p-value is going to be the same as probability.
It's supposed to be negative too. So what is it? So it'd be negative 0.01.
No,
Yeah.
probability is never
Yes.
negative.
Negative. Area or probability is never negative.
Oh yeah, that's right.
Yeah.
That's
Yeah,
18.
we're right. Guys, we're right on that because out of the book it says use the applet and you just plug in the z-score and it's the shaded area is your p-value. So it is
So what?
184.
That's so weird. I don't understand why they're giving us new names.
It's
Uh,
I don't know. It's just a different
probability.
section of biostats, I guess.
So according to that, do you reject or keep the null hypothesis?
Well, with what we learned before, if your number is greater than alpha, then you fail to reject. And our number is greater than alpha, so we fail to reject.
Wait a minute. You're saying
Remember questions, where is it, 9 and 10?
yeah, but how is it greater than alpha? Oh, yes, it is. It's 18% rather than 5%. Okay, I see what you mean. Okay.
So you're saying we reject or we keep?
Fail to reject the null hypothesis. Because when p-value is greater than alpha, then you fail to reject.
Okay.
And then when it's less,
But it's equal. Okay, so we're the hypothesis, the null hypothesis is equal to 150,
mhm.
and then the null hypothesis is less than 150. It's not both sides like before. So, but if it's greater than what we tested, I'm confused.
So the only thing that I'm looking at is, so we found our z-score using the alternative hypothesis, which was mu is less than 150. So we took 144 minus the 150, and the reason why we selected the area to the left is because it is less than, so that would be the area to the left. We found our p-value to be 0.184, and that p-value is is greater than the alpha or whatever that A symbol, because the
Alpha
symbol is 0.05, and so yeah, 0.184 is greater than 0.05.
So we failed to reject the null hypothesis.
Yeah.
For 18. Right. I see now.
Cool. 19. So
There are two types of errors that can be made when performing a hypothesis test, which is one involving rejecting the null when the null hypothesis is true.
one.
It's type 1.
Okay.
If we reject the truth, I remember it's type 1.
Yeah. Okay.
Okay, number 20. A researcher decided that instead of using a level of significance of, oh, that's what A means. It means level of significance.
Yeah.
Of 0.05, he will use 0.01. Which of the following will be true? the probability of type 1 error will increase, or
I think
type 2 error will increase, or the probability that the null hypothesis is true will decrease, and his experiment will be more scientifically valid.
it's very small, the probability of
I gotta look at the question in the homework about that. I remember they were opposites.
So what we found in the reading right here, can you just...
I'm trying to look.
Where are you at on the reading?
So it's after, what section is this? 4.5, where it says type 1 and type 2 errors. It said that if your level of significance is very small, where did it go? Go down a little bit.
So if the alpha value is very small, the probability of committing a type 2 error would be very large. Conversely, if alpha is allowed to be very large, then the probability of committing a type 2 error will be very small.
I do remember that they were opposite.
Yeah, you're dead on. So yeah, if you decrease the level of significance to 0.01, that means that your type 2 error will increase. So it would be the second one.
B, yep.
Yeah.
If alpha equals 0.5, compute the probability committed in type 1 error.
Okay, how do we do that?
Are we still... Yeah. We're now referring to 16. 16 is 16 through 18. It's not talking about 21, so I don't know what we're using. What data we have to use.
I did that on the last one, though. Or organization.
We're referring to 16, I'm sure. So.
Yeah.
For pretty...
Yeah, like this is like a 1% chance. So wouldn't this be a 5% chance?
So this 0.05?
But that's what we were using in 16 anyway.
I don't know if it's like just like 5, like if you can't put percentage.
Yeah, it's 0.05.
So do we take 17? We just take 17 minus 0.05 and get, is it that simple? Just taking 0.134? 0.134?
Awesome, dude.
Is
We're looking it up in the book right now. I'm not finding anything yet.
So
How to compute. Like type 1 error?
Yeah.
So what?
I don't think that's.
Yeah. Wow.
Oh, is this the same website?
Yeah, it is.
Okay.
Type 1 and type 2 error.
So, well, look.
Oh, this might be it. So in this decision matrix right here, so we said that it's a type 1 error.
Which means it's just equal to.
Yeah, it's just 0.05. Guys, the answer is just 0.05. The reason why that is, I'll just show you real quick what I found. That's what I thought it was, but I wasn't sure. This right here is like a little, kind of like a decision matrix of type 1 errors. We determined that it's a type 1 error, and so it's just the p-value is equal to the significance.
The probability.
The probability, sorry, is equal to the level of significance, so it's just 0.05. All right.
Okay. We feel confident?
I think so.
We may have to add a 0 on there because we want three decimals. I don't know. All right. I'm submitting. Looks like we had 100%. 95. Wait, I missed one.
He's like.
Number 5.
Number 5.
It was null hypothesis.
Number 5 is null hypothesis. What the?
You suggested that, didn't you?
Yeah. Yeah. Anyway.
Is that why is that null?
That's extreme. This one. I have no idea. I need to read more about this.
Oh my gosh, whatever.
Sorry, Jason.
Hey guys.
Alright.
Yeah, on Tuesday. Oh, how'd you guys do on the test?
I got an 86.
Dude, good job, Kelly.
What did you guys get?
79.
29.
I got 9.
Did you say 99?
89.
89.
Shiz, son.
I know, one question away from an A, dang it.
What did your friend say she got?
She got
an 80.
80.
Oh, I thought she said she got 99. Oh.
That was my girlfriend being funny.
Oh.
Sorry,
Fiance.
Fiance being funny.
Oh,
Oh,
dang.
she's demoted. You're in trouble.
Alright, good night, guys.
Okay, we'll see you guys
Tuesday.
next Tuesday.
Have a good weekend.
Thanks.
Yeah, you too.